Okay, so here we are reviewing our exponential functions and looking at the review guide where we have a population of 1,500 insects growing by a factor of 3 every week. And now we want to change that to looking at days t. And so the way that you can think about this is if we set up a little table, we can think of days and the number of insects starting at 0 with 1,500, then going 1, 2, 3, 4, 5, 6, 7. And by the time we get to 7, we've multiplied it by 3. So what that means is I'm multiplying by a certain number over and over and over again. And that number that I'm multiplying by is, I'm just going to use the letter R for what our ratio is. And so that means I can think of 1,500 times R and just count up how many R's there are. There's 7 of them. So it's R to the 7th equals 4,500. I've multiplied by R 7 times in a row, and so I'm using the 7th power to represent that. In other words, if you divide both sides by 1,500, you get that R to the 7th is tripling, or that R is the 7th root of 3, which is the same as 3 to the 1/7 power. So we're looking for two different equations that use the 1/7 power. This first one, A, is not right because that triples every day. Second one, B, is right because that has the 1/7 power right there in the exponent. So that means that if t is 7, you have 3 to the first power, meaning after 1 week it's tripled once. If t is 14, that's 2 weeks, and 14 divided by 7 is 2. Part D is wrong, or part C, is wrong because t is not an exponent, so it's not tripling. Part D is correct because it breaks it apart using my R value and raising it to the t. So keep in mind that if you are doing something, if you are multiplying by a number every t days, every t units, then you're going to divide by that value in the exponent. It's like when we did rise over run. If you add 5 every 3 days, then your slope was 5/3. Here it's if you multiply by 3 every 7 days, you have 3 raised to the t over 7, which is the same as doing the 7th root of 3. Okay, now looking at number 2, tuition 21,000 in 2008. Between 2008 and 2010, it increased by 15%. So because I'm reading increased by 15%, I'm thinking 1.15. Because it took 2 years, I'm thinking we're going to have a t divided by 2. And I can multiply that by 21,000, and I know I'm going to have my whole equation. So now I'm looking through all of these statements to see which ones are true. So A says the tuition cost can be defined by 21,000 times 1.15 to the y over 2, where y represents years since 2008. It's totally good. That matches exactly what I wrote. Now question B says it increased by 7.5% each year. That's tempting because you think 15% over 2 years, half of 15, 7.5. That's not correct though, because if it goes 7.5% in the first year and 7.5% in the second year, that's going to be more than 15% over 2 years, because adding the first 7.5% makes the second 7.5% bigger. So it turns out that the answer is C, 7.2%. And the way you can get that is by taking your expression and plugging in 1. 21,000, 1.15 to the 1/2. If you do that, you get this number here. See how I typed it in? There we go. That's how much you pay after 1 year. Now divide that by the initial amount. if you look right there, you see it's actually much closer to 7.2%. Okay, so I did the 1 year value divided by the original value, and I got approximately 1.072, which is a 7.2% increase. By the way, the other way to do it is to raise just the growth rate to the 1/2 power. This is exactly what I was talking about a second ago, where if you're multiplying by a number every 7 days, you have the 1/7 power. Now it's every 2 years, you have the 1/2 power. Now part D turns out also to be correct, and this might be surprising that about 7% a year is going to double over 10 years, because naively, you might think 7% a year for 10 years would be 70% increase. But that's not true, because each 7% increase is bigger than the previous one, because you are doing 7% of a larger amount. The way you can prove this is if you just use your equation again, 21,000, 1.15 raised to the 10 over 2. See how I typed it in right there? 10 over 2. That number right there is about twice as much as the original number. If you don't see that, you can just divide by the original number. Right there. And you'll see that it's just about doubled. And if it doubles every 10 years, that means that part E is also correct. 21,000 times 2 raised to the D, where D stands for decades. So that one was tricky. Only part B was incorrect. The tempting wrong answer. You cannot take a 2-year growth rate and divide it by 2 and treat it like a 1-year growth rate. It doesn't work that way. All right, let's see what's going on down here. So now we've got medicine remaining after H hours. So I can tell here that we are starting with 300 and we are losing 1/4 because we have 3/4 remaining. What does M of 0.5 represent? It represents the milligrams of medicine remaining after the 0.5 hours. It doesn't even actually ask me to get the number, but I'm always interested in what it actually comes out to be. So it turns out that you would have about that much remaining, 259, 260 milligrams. Now we have our graph. If I want to estimate M of 0.5, I go from 0.5 on up and look over here, and so I'd say 260-ish. Of course, I use the calculator, and I know it's 259.8, so pretty darn close. Now, suppose medicine is administered at noon. Use the graph to estimate the amount of medicine at 4:30. So it's 4.5 hours. Go over there. Go over there. It's kind of hard to tell. So it's a little bit above the line in between 50 and 100. So I'd say like 80. I could go back to my equation and type in 4.5 and get a better estimate. 82. Okay. Moving on to number 4. Remember, fish is growing exponentially. As soon as I read that it's growing exponentially, I know that we're multiplying. So I start thinking, oh, what am I multiplying by? 40 divided by 10 is 4. They gave us easy numbers here, but it doesn't matter what the numbers are. You always just divide later number divided by earlier number, and that's your multiplier. So I see times 4. So I know I'm going to go times 4 again for the equal amount of time. Equal amounts of time multiply by equal amounts. So 40 times 4, 160 times 4. Equal amounts of time multiply by equal amounts. Now, that's my 2-year growth rate. So I know that 4 raised to the 1/2 is my 1-year growth rate. It turns out to be the same as half of 4. But I really hate that example because people take the wrong idea away. It's not because it's half, it's because it's the square root. If I fill in the number here, times 2 is 20, times 2 is 80, times 2 is 320, And you can see how that smoothly fills in the missing numbers. So it grows every year by the square root of 4. Last one here. We've got a lake, 11 square kilometers, decreasing by 2% each year. So then they told us this model. Really, you should be able to come up with this model just from the words up until this point in the sentence right here. By what factor does the area decrease in 10 years? So let's just look at what a of 10 is. 11 times 0.98 to the 10th. If I do that, I get about 8.988. So I'm just going to divide that by 11. Is 0.817. So by what factor does it decrease? If I do 1 minus that answer, I get it as about an 18.29% decrease. By the way, you could have done that just by taking the factor itself, 0.98, and raising it to the 10th, and you'll see you get the same number. Okay, so you can either do it by using the original equation or by just isolating the factor itself. Remember that whatever number you get needs to be compared to 1. 1 is the number that keeps things the same. So if it's smaller than 1, you figure out how much smaller than 1 it is, and that's your decrease. Similarly, if it's bigger than 1, the amount bigger than 1 is your percent increase. Now that's per year. So how much does it decrease each month? What you can do is 0.98 raised to the 1/12th, which is the same as doing the 12th root. This makes sense because there's 12 months in a year. And if I do that, I get 0.998, which is approximately 0.2% a month. Okay, so there you go. Please comment if there's anything confusing. Let me know, and I can do more examples on anything or explain if something was challenging. Thanks.